Good morning, good afternoon. This is Gary again. I'd like to thank you all to join our online session, episode 5, color adjustment. Before we get started, I want to explain a few basic things just to make sure everybody is on board. We're roughly doing 30 to maybe 40 minutes demo, including a few slides of presentation. Due to we have a large group gathered today, so I might not be able to open up everybody's microphone. But I do want to encourage you to type your questions in the chat window. We've got a team of engineers standing by to answer your questions in the chat. For those of you who are not very familiar with color light control system, you can check our previous webinar recordings on YouTube by searching color light technology. We usually upload the webinar recordings to YouTube for you to review after every session. Please follow us on Facebook, LinkedIn, or YouTube to receive our future course agenda and latest technology information. And don't forget to send us feedback. Let us know what you want to hear and let us know what you want to see in other sessions so that we can continue to improve and make this better. Let's go ahead and get started. What I'm going to be talking about today is the color basis of LED screen and explain why it's necessary to adjust the color. Then we will have a live demo showing the how easy to make color adjustments over iSet software. In the end of the session, I will also open up someone's microphone if you have any questions, and we will try to get them answered in real time. Let's start by looking the color basis. Technically, color consists of electromagnetic waves from a small region in the spectrum that are detected by the eye and interpreted by the brain. When we're talking about a color in LED screen industry, we are generally talking about images that are made up of red, green, and blue. Each display on the market, whether they are a giant LED wall, TV, or monitor for a computer, all display images starting at the same level, the pixel. Pixel in LED screen is a tiny lamp capable of displaying any one color at a time. When the pixels are lined up properly and presented as a whole, a complex image will be perceived by the viewer. While we perceive each pixel as just one color, pixels are actually made up of 3 subpixels: red, blue, and green. By combining varying values of the subpixels, it's possible to produce numerous different colors at the pixel level. Color is one of the most important aspects when we buy a LED screen or design a project, but color is also a very abstract concept. How do we describe a color of a LED screen? We usually use color space to describe the color performance. Color space defines the range of colors that an LED screen is able to produce. A widely used color map called CIE Chromaticity Diagram, which is also used in our software for making color adjustments, is a very useful creation. It gives us a common language to describe colors. Here is the chromaticity diagram with all colors filled in. Contained within the figure is the full gamut of colors that we can see, all specified by 2 coordinates, X and Y. Each triangle in this figure stands for color space. In this example, they represent some common standard color spaces, such as DCI-P3, Adobe RGB, and etc. The size of the triangle represents the range of the colors that a LED screen is capable of producing. I also would like to explain 3 terms that are used in our software: original color space, target color space, and actual color space. Original color space refers to LED screen's nature color space. It's been determined since LED screen or LEDs being manufactured. Target color space is the one that you want your LED screen to achieve. It's usually smaller than original color space. The actual color space is an approximation to a target color space if the original color space is not 100% cover the target. The actual color space could be the same with a target color space, only when original color space can fully cover the target. With all being said, color adjustment is essentially changing the LED wall's color space. Its color space can be only narrowed down. Why do we need to make color adjustments? Well, there are usually 3 scenarios where color adjustments is required. The first one is color variance between multiple brand or type of displays. A good example will be a stage where you have both LED wall and LCD panels are showing the same content, like the picture here in the slide. The red in the LCD panel is a bit darker than the red on the LED wall. We can set LED wall color space to match the LCD panels. The second scenario is where you have different batch of LED panels in the wall. As you may know, different batch LED panels are definitely not the same color space, which would cause uniform color across the wall. Our software can recognize each LED panel's color space and intelligently choose the best color space that can fit all panels. The third scenario is where the image displayed on the LED wall is different with the source image. In this example, Coca-Cola's red is not accurately displayed because the LED wall's color space is not set correctly. Our software will provide a visualized interface to help users setting a particular color towards a target color space. At this point, I guess maybe some of you cannot wait to see how easy we can do a color adjustment over iSet software. Before we get into demonstration, I want to take a moment to explain the demo setup here. We've got a small 4x2 LED wall equipped with i9 receiving card and a color meter connected to the computer that are running iSet software via USB cable. Please be noticed that only i9 or certain version of i6 receiving card supports color adjustment. The iSet software currently is only compatible with color meter PR655 and CS2000, but we're open to integrate more color meter models into our software. We've also got a web camera standing right in front of the LED wall to ensure that everybody can see the real-time reactions of the wall to the possible changes made on the iSet software. If you're running a Zoom in a computer, you can hold and drag your mouse on the corner of the camera window to resize it in case it's not big enough to see the details. If you're using Zoom, watch this in a cell phone. You can tap on the camera window or share screen window to switch back and forth between them. Now, let's get into the demo. Let me drag the software. There we go. I will not go over all the features that iSet software in this course. We did another demo for iSet a few weeks before. Please review the recordings on YouTube if you want to learn more about the software. So let's go straight to color and brightness tab. This is where we do most of color adjustments. Always click read the screen information first. On the right side of the software is the configuration panel. The dark area on the left is the canvas where it shows the LED panels layout. Each little square on the canvas indicates a cabinet, which is also known as a LED panel. To be more specific, each square is actually representing a receiving card. Sometimes a cabinet could have 2 receiving cards, but in this demo, each panel only has 1 receiving card, so there are 8 panels in total. You may also notice that the left 4 panels and the right 4 panels are having different background color. This means these panels are not coming from the same batch. Probably you can see the color difference of 2 sides on the screen through the camera window. If it's hard to see the color difference, we can pull out the solid color test pattern on the screen display, so that you can quickly find out the color variance on the screen. So how the software knows these panels are coming from 2 different batches. This is because the panel's original color space has been saved to the receiving card. When we read the screen information, we also read its color space setup. I will show you how to save the original color space data to the screen. Click the panel on the canvas which you want to set the colors. You can hold the Control key to do multi-select. I'm selecting 4 panels in the left. Then click Original Color and Brightness button on the right side. Usually your LED wall manufacturer will provide you original color space data file or save the data to receiving card before the LED wall gets shipped. If you already have the original color space data, you can manually type the values in these boxes, or select the preset which has been saved to the receiving card, or you can import a color space data file from local storage. In many cases, LED wall manufacturer does not have the original color space data or haven't measured the LED wall's color space due to limited lead time or some other reasons. Users can use any color meter to measure the LED wall's color space by their own and type the measurements in the software. If your color meter can communicate with iSet software, all you have to do is just simply run a USB cable from the color meter to the computer that is running iSet software, then pointing the color meter towards the LED wall. Click Chroma meter measurements to start a measuring process. The video processor will send a solid red, blue, green, and white pattern to LED wall automatically. The color meter will start measuring primary colors and white. And iSet will read back the measurements data from the chromometer in the meantime. In this demo, I will not demonstrate the full process of automatically color measurements, as it's gonna take 5 to 6 minutes depending on the environment light. So let's close this. Just be pretending we have done this process. After measuring process done, we can save the original color space data to the LED panel, or save it as a preset, which is saved in the panel itself as well. Do the same process to set the other 4 panels in the right. To save our time, I will not demonstrate it here. It's been said before we started this session. After we set up original color space, the next step is to match the colors between these panels. Click on the canvas and select the panels you want to adjust. You can select any 2 individual panels from different batch. In this demo, I will match all 8 panels color. Use Ctrl and A to select all. The shortcut key combination is similar to the Microsoft Office. Ctrl A to select all. Then toggle enable adjustment. You will see a green circle in the center of each panel, meaning that all panels has been enabled color adjustment. Then click multi-batch adjustment over here. Let's look at the CIE chromaticity map on the left first. There are 3 triangles represents 3 color spaces. The red and green triangles represents 2 different batch of LED panels respectively. The black triangle is the color space after batch matching. Let me try. That's the black triangle. It's calculated by iSet software. The colors in this black triangle is the common color range that both batch can reproduce. And we can save the color space to both batch of LED panels. This is the whole process of matching LED panels color between different batches. It's super easy, and you just need to do a few clicks on the software. As I mentioned earlier, there's a scenario where the users needs to set their LED wall to a target color space. Let me demonstrate how we do that in iSet. I'm going to reset all color adjustments we have done previously. These color settings are on the top of calibration data. In other words, the color adjustments will not affect calibration data. Click Advanced, like this. Click the Advanced Adjustment. There are 2 optional modes in this window, RGB and CMY. RGB stands for red, blue, and green color. CMY stands for cyan, magenta, and yellow. Doesn't matter which mode you're using, they both would achieve the same effect eventually. The reason we designed two options to help users who need quickly set up a particular color to a target color space, not only primary colors, as well as secondary colors. This sounds might a bit confused. Let me take an example. Say magenta color displayed on your LED wall looks a little reddish. So we need to move magenta point on the map opposite to the red color to reduce the color from the red color from magenta. We can also lower the X coordinate value in the target color space table. As you can see, the magenta point moves backwards, the red in real time. This real-time visualization greatly helps users quickly relocate a color in the color space. iSet software also has built-in many standard color spaces, such as sRGB, DCI-P3. Users can either choose its inbuilt color space or custom a color space. Select custom over here and type the custom target color space coordinates in the table. Sometimes the original color space cannot 100% cover the target color space. In such situations, iSet software will work out a gap between original and the target color space. For example, I'm selecting DCI-P3 color space as my target. If you look at the triangles in the CIE map, the black triangle represents original color space. The dotted line triangle represents the target color space. Obviously, my demo LED wall original color space cannot hit DCI-P3. iSet will take common colors between two spaces, which represented as a white triangle. All colors in this triangle is the actual color space. The actual color space can be modified as well. We can change the white point coordinates in this table to precisely set LED wall's color temperature. I'm changing the values here, and you should be able to see the white point in the CIE map moves. All color adjustments made in this window can be saved as a file or export the file to a local disk. You can click Save the button, directly save it to the LED wall. Another situation I want to point out is users sometimes does not have a target color space. They don't know what target color space should be set. Just simply doesn't feel right about maybe the colors on the LED screen is not look right. Well, in this kind of cases, we can use simple adjustment. Select unknown it means you have no idea what your target color space will be. Press Simple Adjustment button. For example, if the magenta does not look good to you, or it does not meet your customer's requirement, select magenta. You can send a solid magenta test pattern to the screen by clicking here. The test pattern will help you to quickly and easily identify the colors on the LED wall. Once magenta has been selected, the sliders on the green bottom here will be grayed out, because magenta is a mixed color with red and blue, nothing to do with green. On the red section, there are capital R and lowercase r, RG, and RB sliders, representing the red light intensity, the green light intensity, and the blue light intensity in each pixel respectively. To keep it simple, it's actually representing the amount of red, green, and blue in the red image. Same as to the blue, it's also got 3 sliders. By dragging these sliders will allow us to mix in colors to achieve a desired color. If you look at the camera window, you should be able to see the LED panel in the lower right are changing its color. Please be aware that all these color adjustments are made inside LED wall's color space. The LED wall cannot produce colors that it is not capable of. However, with simple adjustment, the LED wall will take effects immediately to adjustments made on the software. It might not be as precise as advanced color adjustment, but it makes users be able to adjust the color by eyes without knowing a color space coordinates or using a color meter. All right, I think this is going to be all that I want to demonstrate regarding the color adjustments today. The next course, we will cover seamless correction on May 12th, next Tuesday. If you have any questions regarding color adjustment, please raise your hand or send your questions in the chat. We will get them answered in real time.